Welcome back to the Allen Park Public Library for our Summer Reading Tech Tuesday. I'm Mad Dan. Let's get right into it. This experiment is going to go into how wind currents form and are felt. We have two candles here. One of them is going to go lit inside of the box, which will warm up the air inside of the box. The colder outside air is heavier. Hot air will want to leave and to go through it. We have a second candle that is going to be outside of the box, and we're going to see what happens to that smoke as these air currents of hot and cold air interact. We've got the plastic in front of the box so that we can actually see what's happening. We're going to light one of the candles and then put it inside of the box using the hole on the bottom of the box. That is going to create warmth inside of here, which when we blow out the other candle, the smoke will go in on the wind currents into the box and out through the top hole instead of all just going up in smoke. Boom. Having a parent light the candle and then put the candle in the box, and let's see what happens. So now we're going to blow out the candle and see what happens to the smoke. So a lot of the smoke went wafting into the warmer box because the cool air is creating a slight draft, and the smoke is light enough that even that light draft is enough to move the wisps of smoke away. This experiment is going to demonstrate how pressure works. Now, we've talked about pressure before on Mad Dan, and we are going to use this water to simulate any sort of medium that will have pressure. We have a cup with two holes in it. We're gonna fill this cup up faster than the holes can drain it and see what happens as more liquid goes in the cup, creating more pressure. So we've got our pitcher of water, which is going to come out much faster out of the pitcher than out of either of these holes. So the cup will fill. As the cup fills, the pressure will build, and we will see what effect that has. We see that the water is coming out of there, and then as we pour more and more, the bottom hole is flowing farther and farther. You can see it just trickling out of the top hole, but the added pressure is making it pour completely out of the bottom one. So the more pressure, the stronger the force on it. One of the most powerful forms of weather in the summer are tornadoes. We're going to use these 2-liter bottles and this water to simulate how a tornado forms. And then we're going to use this open-topped one so that we can actually watch what will happen as the storm is raging. We're going to use this little bit of water and all the air that is trapped in here. We have a washer in here that is narrowing the gap even further, and that's going to really let the water, when it starts spinning, really form a nice funnel cloud. When we are creating this cyclone, we're spinning the water and it's creating a tunnel between the two bottles. And that tunnel is letting the bottom air escape up and forcing the water to keep spinning down. As it gets closer and closer to the opening, it's spinning faster and faster. And that speed is what is causing it to rain down. And then there's actually that tunnel of air all the way up through the center. And we're going to examine that now. Here is the washer. What I'm going to do is I'm going to actually put it on some tape, and that's just going to create a little bit of a better seal as I fasten it onto the top of the one empty 2-liter. So with a parent or guardian to use the knife to cut out the hole around the washer, we then seal this guy together and take another wrap of tape, lightly seal. Now, this is duct tape. It's not waterproof. It's not supposed to make it watertight. It's just supposed to help us be able to manage these two large bottles without needing a bunch of people to hold everything steady. We are ready to examine the eye of the tornado. And you can see that nice solid tunnel that the bottom air is cycling up through, and then that's allowing the fast spinning water to empty itself down the same way that a tornado in, say, the Midwest, the hot air goes up through the funnel and the cold air rapidly spins down and causes the destructive twister that you see. Thank you for joining us here at the Allen Park Public Library for our summer reading program. I'm Mad Dan. Be sure to subscribe and follow us, and we will see you next time.